Hi friends, so welcome to Machine Learning Journey. This is lecture 9 of our ML series. So before I start the lecture, I will recap what we studied in the previous lecture. In the previous lecture, we studied about linear regression, where you make the assumptions that the data you have given, which is the pairs, X is the input and Y is the output, labeled output, and you have some pairs. With this, you assume that this will fit in a linear equation y equals to mx plus c. With some algorithm, you try to figure out value of m and c. With some method, with some algorithm, with some steps, you figure out the value of m and c with the given x and y, and then you say that these are the my model. Let's say you have, let's say after going through algorithm, after following the specific steps, you get the value 5x plus 3. So this is your equation which will fits in the sorry, this is not the rough, not even the rough diagram. How to erase it? Okay, 5x plus 3 means plus 3 is here, intercept. Okay, so now in this lecture, what we'll do, we will understand you have one model, you have test set also, test set data set or test data set. Now you want to know how much accurate this model is. How will you figure out what exactly you will do? You have in test set, you have pairs of X for this input, Y actual output or ground truth. Okay, what you will do? You will calculate. First, you will test it. So you have predicted values. Sorry, okay, you have actual values and you have predicted values. Let's say for model M1, whatever you have created. So for example, when your actual value is like 4 for some model, let's say marks you get by number of hours you study, that is input, and the marks you get is output, let's say something like that. So in that, let's say actual output is 4, your predicted is 6, your actual value is 6, you predicted 4, the actual value is 3, you predicted 4, let's say. So how will you figure out the error? The first intuition or first things which can like come to your mind is like, what if we just subtract it? So because you want to know how far my actual value is from how far my predicted value is from actual value. So we will simply subtract it, correct? So let's say you subtract it from actual value to predicted value, actual value minus predicted value. That's what error definition is. So in simple terms, the error is difference between actual value and predicted value. Okay, this is the error definition. Now do it. Actual value is 4 minus 6. This is error 1 in the first example. 6 minus 4, error 2. For the second example, 3 minus 4, error 3. Now you have different errors. Now let's say you just sum up this all the errors to know that the overall what is the error for the models. So you just sum up it. It is minus 2, it is plus 2, it is minus 1. It is overall minus 1 error. And what if there is one more example and it says that the actual value is 4 and the predicted value is 3 and it gives you 1. So minus 2 plus 2 minus 1 plus 1. Are you able to see something weird or something which it should not be? With this subtracting actual value minus predicting predicted value, it is cancelling the negative values with some positive values. So overall the impact or the interpretation will goes wrong. For example, if your model M2 says that your actual value is 4, predicted 4, actual value is 5, predicted 5, actual value is 6, predicted 6. Now overall error will be 0 here, 0 here, 0 here, and overall error is also 0 for all the examples. So M2 says total error is 0. M1 also says total error equals to 0. So how will you figure out that which model is true or which model is good. So you know that M2 model is good, but mathematically you are not able to see it because the positive and negative value are cancelling it. So what you can do is you just take the absolute value of your error, predict actual minus predicted. This is your error. Take as an absolute value, then it will become absolute error. Okay. Now you can think about like -2 will become +2, +2, +1, +1. So overall, the M1 model error is 6 and M2 is still 0. So you say that, okay, M2 model is 0. M2 model, sorry, is good. Now, now let's say this is a lumber line, okay? And this is actual minus predicted values, absolute values, 5, some model, some other model which is saying 7, some other model M3, and some model M4 which is saying, let's say 91, and M4 saying error is 93. Now what I am saying is, when you see a model M1 and M2, you say that, okay, M1 and M2 model has a difference error of 2, and M3 and M4 difference error is also 2. So can you just make a can you make a conclusion that the way we are comparing M1 and M2, should we compare with same as M3 and M4 also? So here the basic sense or basic intuition is like the larger error should get more penalties. Why? Because the more larger the error is, the interpretation with the corresponding models should not be compared same as the smaller errors. So here, if you just take the absolute value is still making sense because it is cancelling the negative values. But for the larger values, still holding the same problem. So now if you take the square of the whatever absolute value you get, then this makes more sense. Now the error 5 goes to 25, 7 goes to 49. Now 91 goes to 91 into 91, and 93 goes to 93 into 93. So now the difference is large as compared to this difference. This difference is just 24, and this may be very large number, right? It may be in thousands. So this value is more is now is a interpretable that, okay, this M1 and M2 are close enough at least, and M3 and M4 are more far because the quantity of error is increasing. So here the thing is, in machine learning we use squared error. Why we use it? Because to give penalty to larger penalty to large error, to large errors. So the more the error model makes, more penalty it gets. So now you have 100 examples, let's say 100 examples in the test set, 100 cross 2, x and y. So for all 100 values, you have the squared error. You calculate actual value, you have actual value, sorry, you calculate the predicted value, and then you take the square and you have value E1, let's say E100, all the errors you have. Now if you take mean of it to get the average value of all the values, all the errors, so that you can interpret it better. If you just sum up it, it will keep increasing. So take the average for each example where it's lying. So now if you take the average, which is like E1 to E100 by 100, then it is like mean, you took mean of what? Squared of error. That's what MSE is the most famous cost function in machine learning for linear regression. For linear regression, mostly we will use this error. And this is what the cost function is. The cost function is to calculate the error, or it is a mathematical function to calculate the uh, values, to interpret the how good your model is, or to calculate the errors. Okay. Okay, now we will understand like what does training actually mean. So what is linear regression trying to do? It is trying to reduce the cost. You have the function cost function, which is like, let's say, mean squared error, which takes 1 by n, let's say, summation of I1 to n, actual value minus predicted value. Okay, and taking the square. This is your equation. And you want to reduce this as much as possible to get the best values of m and c. Okay, you first assume some value m and c, and then you take you calculate the predictions for each input in the training data, and then you check how much error it is, and then you take one step, which is differentiation with respect to each variable. We will discuss in detail in the next lecture, but as of now, you just understand that we do some step and we try to get the M and C value, good M and C value, so that this mean squared error reduce as much as possible as. Okay, so this is all about this lecture. Just 1 minute, I will recap it. So you make the prediction. This all we are doing in the test set to interpret the how model is performing. In the training set also we calculate the errors so that we get the best value of MNC. But once the MNC we got from the training data for test set also, we will do same step. So you have predictions, you calculate the error with cost function, and then you 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 get some values and you interpret it whether it is good or bad. So in this lecture mainly you understood that what is the cost function. It is just to mathematical function to figure out what is the error value for your model. And why can't we take just simply sum of the error, because the negative and positive value cancel out. So we take absolute value. Now for the larger errors, the model should be given a large penalty. Making a 5 error and making a 25 error should not interpret as, let's say, actual value is 1 and you're getting a 5 value and your one model is getting 25. So 5 minus 1 is 4 and 25 minus 1 is 24. 24 and 4 has a difference of 20, but that 20 needs not to be always linear. More the error you make, larger error you make, larger penalty should be. So in this lecture, we understood this cost function. In the next lecture, we will understand about gradient descent and how we exactly calculate the M and C values.